In this lesson we're going to have a look at a couple of density calculations so that we can practice using the density formula. So the first problem, we see the diagram below is a cube of oak wood of length 10 centimetres, and we're asked what is its mass if the density of the oak is 0.7 grams per cubic centimetre. So in all problems what I recommend you do is to write down clearly your starting formula. So we need to remember that the formula for density is equal to rho normally, although I think D is pretty much acceptable, but technically we should use rho for density is equal to the mass divided by the volume. Now in this particular case we've got what is quite typical, which is a two-stage problem. We're told what the density is here, it's 0.7 grams per cubic centimetre, and we've got to find the mass, but we haven't been explicitly told the volume. You have to work that out. So this is a two-stage problem, and this is an easy problem because it's a cube, and you know that the length and the width and the height of the cube are all the same, and they're equal to 10 centimetres by 10 by 10. So you should know then that the volume of a cube is equal to its length multiplied by its width multiplied by its height, which is equal to 10 times 10 times 10, which is equal to 1,000 cubic centimetres. Alright, so we've got our volume, we've got our density. What we've got to do is find the mass. Now that means we need to rearrange this formula so that we have the mass on its own, and if you're a little bit ropey about doing that, then I suggest you use a calculation triangle. And remember, when we have the format something is equal to something over something, that's the division bar, then this something divided by something slots in here. So we have the mass divided by the volume, and the other term here, in this case the density, slots in like that. So in this case we look to see what are we trying to find. Well, we're trying to find the mass, so in the calculation triangle we will cover up the mass. You cover up the term that you're trying to find, and that gives you density multiplied by the volume. So we can write that the mass is equal to rho times V, and then we substitute our values in. You should write these down beforehand. So you write rho is equal to 0.7 grams per cubic centimetre, and V is equal to 1,000 cubic centimetres, and so the mass will be 0.7 multiplied by 1,000, which is equal to 700 grams. In our next problem we're being asked to find the volume of a piece of lead that weighs 500 kilograms if its density is 11.4 grams per cubic centimetre. So the first thing we're going to do here again is we're going to write out the density formula. So we write out P is equal to mass divided by volume. And I want you to notice here straight away something very important. This is quite often what examiners will do in an exam question on density is this: they will mix the units deliberately to try and throw you off your track. Okay, and this is what's happened here. So notice you've got 500 kilograms of lead, but the unit given for the density is grams, not kilograms, grams per cubic centimetre. Now we don't want that. We cannot mix these units, so we've got to do one of two things. We've either got to convert the 500 kilograms to grams, which is one possibility, or we rewrite the density in terms of kilograms per metre cubed, which is what I'm going to do in this particular case. So we remember that when we convert grams per cubic centimetre into kilograms per metre cubed, then we need to multiply the figure by 1,000. Okay, so whatever figure goes in here for grams per cubic centimetre, we multiply that by 1,000, and that gives us the density in kilograms per metre cubed. So we can write 11.4 grams per cubic centimetre is exactly the same thing as 11,400 kilograms per metre cubed. That's what we're going to use now for our calculation. Both of these mean exactly the same thing. They are simply two ways of stating the density of lead, but this way is the more useful for this calculation. So going back to the formula again, what are we looking for? Well, we're looking for the volume in this case. We've got the density and we've got the mass. So we need to rearrange the formula in terms of volume. What is the volume equal to? Again, if you're a bit ropey with manipulating formulas, remember your calculation triangle. Now, I hope you can remember what goes in here from the previous question, but if you can't, again, we have the formula, which is P, which is rho equals something over something. So the something over something goes in here. So we slot in the mass divided by volume goes here, and the rho goes here like that. And the next step we ask is, well, what are we looking for? Well, we're looking for the volume in this case, so we cover up the volume like that, and that leaves us with mass divided by rho. So that gives us the mass divided by the density. And so then we write out our values. So the mass is equal to 500 kilograms. The density is equal to 11,400 kilograms per cubic metre. Substitute those values in. That gives us 500 divided by 11,400, which is equal to 0.044 cubic metres. Now, I should also emphasise that although the density was originally specified as grams per cubic centimetre, because we made this conversion here where we changed it from grams per cubic centimetre to kilograms per metre cubed, then the final volume in our answer will not be in cubic centimetres, but it will be in cubic metres, the same as we use for the density of lead here. Okay, so that must be in cubic metres.